Well, after integrals, with just a little loopy s there, comes definite integrals. And this is called on the interval from 1 to 3. This is page 13 from A Very Brief Look at Calculus. And we're going to evaluate some definite integrals. The first thing you want to do is find the antiderivative of 2x. What's nice about this is you don't have to do the plus c. So there's a hidden one there, so that's going to give me 2x to the second. And when that's simplified, I got to put it over 2. You put that exponent underneath. That simplifies to just plain old x squared. Now I'm going to set up this notation from 1 to 3. Okay, and now I want to find out what the area is by evaluating this from the interval from 1 to 3. And that means I take this value squared and I subtract it from another value squared. And all I do is plug this value here into the first one and this value into the second one. 3 squared is 9, minus 1 squared is 1, and my answer is going to equal 8. And that's my first definite integral.
Same problem, I'm going to now complete on this Casio. It will do it for you. You see it has an integral button right there. It's a wonderful button on this calculator. So I'm going to evaluate that integral from 1 to 3 of 2x. So I'm going to hit that button, and I'm going to type in 2 alpha x from 1 all the way up until 3. And I'm going to hit the equal sign, and bingo, it gives me the answer pretty rapidly, which is not that good in a calculus class because they usually want to see how you arrived at that answer.
Still working on number 1. A different way to do it is to graph y equals 2x. So I'm going to graph that equation y equals 2x. That means I begin at 0 and the slope is 2. I go up 2 over 1. I go up 2 over 1, up 2 over 1, up 2 over 1. And it says from 1 to 3. So I'm basically going to find the area underneath this line from 1 all the way up until 3. And notice that gives me a trapezoid. That shape there is a trapezoid. And the area of the trapezoid is going to be 1/2 height base 1 plus base 2. So I'm going to find this area instead of using calculus, using geometry. So the height is 2, so I'm going to put 0.5 times the height 2, times base 1, which is 1, 2, 3, 4, 5, 6, plus base 2, which is 2. So that's going to give me half of 2 times 8, which is just going to give me 8, geometrically, number 1.
Number 2, I'm just going to find the antiderivative without doing any fancy lines. There's a hidden 1 there, so I add 1 to that, so that gives me 2x squared. And then I divide it by the exponent. That's going to simplify to x squared. Or in the interval from 0 to 3. So it's going to be something squared minus something squared. And that something is, for the first one, is going to be 3. I take this 3 and I throw it in here. Then I take this 0 and I throw it in the back there. 0 squared is 0, so my answer should be 9.
Let's test that on the Casio. Integral of 2 alpha x from 0 to 3. And yes, it equals 9.
I want to find this integral. First thing I want to do is find the antiderivative. So that's going to be 2x squared over 2 plus 1x, or just x, on the interval from 0 to 4. Notice the 2's simplify. So that's going to give me a double quantity. So that's going to give me x squared plus x on the interval from 0 to 4. And I'm going to set that up with a minus sign in between two quantities, because there's a little bit more involved to this one than just a single term. So that's going to be x squared plus x squared plus x, and now I'm just going to fill in those templates with the values on the interval from 0 to 4, so the 4 goes up front, here and here, and the 0 goes in the back there and there. 4 squared is 16, 16 plus 4 is 20, and then it's nice to see that this is just going to be 0, so my answer is 20.
Let's try it on the Casio. 2 alpha x plus 1 from 0 to 4, 20. Pretty rapid.
Okay, this is the trig function, and notice the interval of the integral is from pi over 6 to pi over 2 of 8 cosine x. Remember, the derivative of cosine, the integral of cosine is sine, not derivative. So I have to find the antiderivative of cosine, and that's going to be sine. So here we go. That's just going to give me 8 sine x, and that's the antiderivative on the interval from pi over 6 to pi over 2. So that means I have to evaluate it at these numbers. So it's going to be 8 sine of some number minus 8 sine of the second number. And what I throw in there is going to be this pi over 2 first and this pi over 6 second. And that's where our unit circle comes into play. You remember this thing. So I need to know what the value of sine of pi over 2 is. The sine of pi over 2 is 1. So 8 times 1 is just going to give me 8 minus 8 times something over here, pi over 6. Sine of pi over 6 is 1/2. So 8 times 1/2. And that's going to give me 8 minus 4. So 8 minus 4 equals 4. And that's my solution to that definite integral.
Let's make sure I'm in radian mode. And yes, I believe I am. There's a little r there. I see the little r. And let's see how well it does with a trig function. Integral of 8 cosine alpha x, close parentheses, you have to be careful, from pi over 6 all the way up to pi over 2. And remember, my by hand answer was 4. It's thinking, and there it is. It took a while to do it, but quicker than me doing it by hand and absolutely more accurate.